Alright, now let's look at this question. We'll first look at option A. It says Azure SQL Managed Instance. Managed Instance offers near complete capability with on-premises server, SQL Server, and handles updates, backups, and maintenance automatically. Let's keep it. We'll move to B. B says SQL Server on Azure Virtual Machines. Azure Virtual Machines require manual management of updates and maintenance tasks. We'll reject it. We'll move to option C. C says Azure SQL Database. Azure SQL Database lacks full feature capability with SQL Server, which is required for migrating legacy workloads. Incorrect. We'll move to option D. D says Azure SQL Edge. Azure SQL Edge is designed for edge computing, not enterprise grade SQL Server workloads. Incorrect. We'll lock option E, Azure SQL Managed Instance, that is SQL MI, as the right choice. Alrighty, now let's look at this question. We'll look at first option A. It says column. A column defines attributes, not individual entities. Incorrect. We'll move to B. B says table. A table holds many entities, not a single instance. That being said, it's incorrect. We'll move to C. C says cell. A cell holds one value, not a full entity representation. We'll delete this. Now let's move to option D. This is row. A row represents one complete instance of a data entity, such as customer or transaction. That being said, row is the right answer. Alright, now let's look at this question. This is all about real-time sales transactions. Option A says a data warehouse. A data warehouse supports analytical workloads, not real-time transaction capture. Wrong choice. We'll move to B. B says an online analytical processing, OLAP. OLAP is used for multi-dimensional analysis, not operational transactions. Wrong choice. We'll move to option C. C says ETL. ETL handles data movement and transformation, not live transaction execution. We'll eliminate it. We'll move to now D. D says online transaction processing, known as OLTP. OLTP systems are designed to handle frequent real-time operations like insert, update, and deletes. That being said, option D is the right answer. Alright, now let's look at this question. This is all about compressed columnar storage. Option A says HTML. HTML is designed for presentation, not structured data storage. Incorrect. We'll move to B. B says CSV. CSV lacks data types and compression, making it inefficient for large-scale analytics. We'll move to option C. C is Apache Parquet. Parquet supports columnar storage with embedded schema and compression, which is perfect for analytical workloads. We'll keep this. Let's move to option D. D says JSON. JSON supports nested structures but doesn't offer columnar compression or typed schema. We'll delete this. Quick tip for the exam: whenever you see columnar storage, Parquet should strike on your mind. This is the Parquet is the golden standard nowadays with respect to columnar storage. So Parquet is a way to go whenever you see columnar storage. We'll lock option C, Apache Parquet, as the right answer. Okay, now let's look at this question. This is all about cloud-based analytics platform. Option A says analyze datasets to uncover patterns and business insights. Analyzing datasets aligns with the responsibilities of data analyst or data scientist, not data engineers. Incorrect. We'll move to now option B. B says set up tools and procedures to manage backup and recovery operations. Setting up tools and procedures falls under the role of system administrators or infrastructure engineers. Wrong answer. We'll move to C. C says develop statistical models to support forecasting and decision making. Developing statistical models falls within the domain of data scientists, not data engineers. Will eliminate it. We'll move to D. D says build and configure storage systems optimized for analytical processing. Building and configuring storage systems aligns with the role of data engineers who focus on creating reliable, scalable data infrastructure for analytics. We'll lock this as the right answer. Alright, back to the basics. This will test your concepts on acid. Option A says atomicity. Atomicity ensures all or nothing execution, not control over concurrent reads. Incorrect. We'll move to B. B says durability. Durability ensures persistence after commit, not protection during execution. Will reject it. We'll move to option C. C says consistency. Consistency maintains rule adherence, not concurrent access control. Wrong answer. We'll move to D. D says isolation. Isolation ensures that concurrent transactions do not read partial or inconsistent data during execution. Looks good because that's what we are required. D. Isolation is the right answer. Alrighty, here we go with an interesting question. This is all about graph database. Option A says table. Table API handles flat key value pairs, not graph relationship. Incorrect. We'll move to B. B says Cassandra. Cassandra API supports wide column formats, not graph traversal. Wrong choice. Option C says Core SQL. Core SQL API stores JSON documents, not graph structures. Wrong answer. So quick tip for the exam. Whenever you see graph database, Gremlin should strike on your mind because Gremlin supports graph based queries and relationships, mapping essential for graph database. So let's lock option D, Gremlin, as the right answer. Alright, now let's look at this question. This is all about Azure storage solution. Option A says Azure Table Storage. Azure Table Storage handles semi-structured data efficiently with schema flexibility and fast lookups. Let's keep it. We'll move to B. B says Azure Queue Storage. Queue Storage is designed for message delivery, not long-term log storage. Let's delete this. We'll move to C. C says Azure Files. Azure Files supports file shares, not optimized for storing structured or semi-structured log entries. Incorrect. We'll lock option A, Azure Table Storage, as the right answer. Alright, now let's look at this question. This is a multiple choice question which is about uniquely identifying. Option A says partition key. Partition key defines the logical boundary for grouping rows. Let's keep it. We'll move to B. B says range. Range is not a structural component in Azure Table Storage. Incorrect. We'll move to C. C says row key. Row key ensures uniqueness within the partition. Looks good. We can keep it. We'll move to D. D says timestamp. Timestamp tracks changes but doesn't define uniqueness. We'll delete this. Let's lock option A, partition key, and option C, row key, as the right answer. Alrighty, now let's look at this question. This is all about automatically deleting blobs. Option A says archive storage. Archive storage changes access tier but doesn't delete blobs automatically, what we are looking. So option A is wrong. Let's move to option B. B says the change feed. Change feed logs events but doesn't perform deletion. Wrong answer. We'll move to C. C says soft delete. Soft delete delays deletion but doesn't again automate it. Wrong answer. We are left out with option D, that is lifecycle management policy. Looks good because lifecycle management policy enables automated deletion based on conditions like age or access tier. That being said, option D, lifecycle management policy, is the right answer. So please don't go away. Let's meet in the next part of this series.